Hello, science fans! Welcome to a new adventure in understanding the hidden world behind the information we use every day. Today, we're diving into the fascinating world of data, where all those facts, figures, and details live and breathe. Imagine if all the world's information was just thrown into one giant, messy pile, with no order or structure at all. It would be like searching for a single Lego brick in a swimming pool full of them. Frustrating, time-consuming, and almost impossible to find what you need. That's why we need a plan, a way to sort and organize data so we can find what we need fast. Just like organizing your desk or closet, tidying up data saves time and reduces stress. This is where data modeling comes in. It's the process of bringing order to chaos, making sense of all those scattered pieces. Data modeling is like creating a blueprint for our information, deciding what to track and how things connect. It's about planning ahead so everything fits together perfectly. For example, in a library we track books, each with its own title, author, and unique code. And we also keep track of the people who borrow them, making sure every book finds its way back home. A data model shows how these things relate, who borrowed which book and when. It's the map that guides us through the information maze. By mapping this out first, we make sure our database is neat, tidy, and makes sense from the start. This saves us headaches later on. Think of it like building a house. You need a solid plan before you start putting up walls, or things could collapse. A good data model ensures our database is strong, efficient, and reliable, able to handle whatever questions we throw at it. When you ask a question, like how many books Jane borrowed last month, a well-organized database finds the answer in a flash, saving valuable time and effort. But if the data is a jumble, it's slow and prone to mistakes. You might even get the wrong answer, or no answer at all. Good data modeling is the foundation of any great computer system. So, let's get started and build something amazing together. Now that we know why we organize data, let's explore how we can make sense of it in a way that's both powerful and practical. Organizing data isn't just about storage. It's about making information accessible, meaningful, and ready for action. One of the most effective tools for this is the Extended Entity Relationship Model, or EER. This model helps us visualize and structure data in a way that mirrors real-world complexity. The basic ER model is like a simple sketch, showing main things and their relationships, like students enrolling in courses. It's a great starting point for understanding connections. But real life is more complex. The EER model adds detail, letting us handle groups and subgroups, like full-time and part-time students. It helps us capture the nuances that matter in real scenarios. It's called extended because it introduces new concepts for more complex situations, such as inheritance, specialization, and categorization. Think of the animal kingdom. Animals split into mammals, birds, and fish. Each group has its own unique traits, but they all belong to the broader category of animals. EER lets us draw this structure, showing how different entities are related and organized in a hierarchy. This makes our data model clearer and easier to understand, so everyone on the team can see how information flows and connects. With EER, we can build business rules right into our design, like only postgraduates can enroll in thesis courses. These rules help enforce real-world policies directly in the database. This ensures our database behaves exactly as it should, reducing errors and making systems more reliable. EER adds precision and intelligence to our plan, saving trouble later by anticipating challenges and clarifying requirements from the start. It's a smarter way to design databases, combining science, logic, and creativity. That's data modeling in action. Let's zoom in and take a closer look at how data is organized in the real world. One of the coolest features of Enhanced Entity Relationship, or EER, diagrams is the use of supertypes and subtypes. Think of a supertype as a big, general group that holds common traits, while a subtype is a smaller, more specific group within it. For example, in a library system, library item is the supertype that represents all items you can borrow. Books, magazines, and DVDs are the subtypes. Each one is a specific kind of library item. All these subtypes share certain features, like a title and barcode, which are listed just once in the supertype to avoid duplication. But each subtype also adds its own unique details, like an author for books, or a director for DVDs, or even an issue number for magazines. This approach keeps our data model neat, organized, and prevents unnecessary repetition, making updates and maintenance much easier. The same principle applies in a hospital. Employee is the supertype, and doctors and nurses are subtypes, each with their own roles. Every employee has a name and staff ID, but doctors have specializations, and nurses have ward assignments, showing how subtypes add detail. In EER diagrams, we connect the supertype box to each subtype box with a circle, visually showing their relationship and hierarchy. This makes our data blueprint clear, logical, and easy for anyone to read or understand at a glance. Anyone can instantly see how categories and groups fit together, making collaboration and communication smoother. It's a powerful way to represent even the most complex relationships in a simple visual format. Supertypes and subtypes help us organize information efficiently, saving time and reducing errors. You'll find this structure everywhere, in libraries, hospitals, businesses, and countless other real-world systems. That's the magic of EAR, bringing order and clarity to the way we manage and understand data. Now, let's talk about inheritance, a key idea in data modeling. Inheritance means subtypes automatically get all the attributes of their supertype. For example, every doctor is an employee, so doctors inherit name, address, and staff ID from the employee supertype. We don't have to repeat these details for every subtype. Each subtype just adds its unique attributes like specialization for doctors. This reduces redundancy. No more repeating the same information everywhere. If we had 20 types of employees, inheritance saves us a ton of work. It's the ultimate don't repeat yourself rule. When we build the database, this relationship is real. Dr. Smith is both a doctor and an employee. The system knows where to find her address, under employee. Inheritance makes our database smarter and more connected to real-world logic. It keeps our models elegant and efficient. That's the beauty of inheritance in data modeling. It just makes sense. Big data models can get messy, like a map with every street and building. To manage complexity, we use entity clusters, virtual boxes that group related entities in our EER diagram. For a university, we might cluster student, course, and lecturer into academics. Clusters make diagrams easier to read and help us focus on one part at a time. They're like folders on your computer, purely for design, not the final database. Clusters help us break down big problems into manageable chunks. By grouping related entities, we keep our blueprints clean and less intimidating. It's a simple, brilliant way to organize complex systems. Every database needs a way to tell things apart, a unique identifier called a primary key. A primary key uniquely identifies each record, like a student's ID number. Natural keys are real-world unique attributes, like a car's VIN. But if a natural key isn't unique or can change, it's risky. Sometimes we use composite keys, 2 or more attributes combined, like student ID and course ID for enrollments. Often, the safest option is a surrogate key, a made-up number with no real-world meaning, like a customer ID. Surrogate keys are simple, never change, and always unique. The database can generate them automatically. Choosing the right key is crucial for a reliable system. Primary keys unlock the power of your data. They keep everything organized and accessible. Without them, data gets lost in the crowd. That's why keys matter. Once you know the basics, you'll face tricky design situations. One-to-one relationships. Sometimes, one entity matches exactly one other, like a person and their passport. If every person must have a passport, you might merge the tables. If not, link them with IDs. For optional relationships, like not every employee being a manager, keep separate tables and link with a manager ID. Another challenge, time-variant data, tracking changes over time, like job history. Instead of overwriting job titles, use a separate job history table with start and end dates. This way, you keep a complete record of changes. Handling time-variant data adds complexity but gives you richer insights. Advanced data modelers plan for both current and future data. It's all about thinking ahead. As models grow, problems can sneak in. A fan trap happens when relationships create ambiguous paths, like knowing which department a lecturer belongs to, but not which course they teach. The fix? Add a direct link between lecturer and course. Another issue: redundant relationships, extra links that repeat information. For example, if a student enrolls in a course, and the course is run by a department, you don't need a direct student-to-department link. Redundant links cause confusion and inconsistency. Always check if a relationship is truly needed. Clean models have no unnecessary parts. Avoiding traps keeps your data accurate and your design simple. Good modeling is about clarity, not clutter. Keep it clean. We've journeyed from messy data to advanced modeling concepts. Data modeling isn't just drawing boxes. It's about building a logical, efficient blueprint. The EER model gives us tools like supertypes, subtypes, and inheritance for real-world accuracy. Choosing the right primary key ensures every piece of data is unique. Handling special cases and avoiding traps separates good design from great. A well-designed database is faster, more reliable, and easier to update. It adapts to new needs without a complete overhaul. Good data modeling makes information trustworthy and useful. By designing carefully, we build a solid foundation for knowledge and discovery. Build a good model and change the world.